All right, folks, welcome back. So I hope you had a chance to stretch your legs a little bit, maybe get some coffee, have a body break. But we are now moving on to section 3.1, okay? So 3.1, you can find the blank notes in Canvas, all right? And so we're gonna jump right in. I'm gonna share my screen and we'll go from there. All right. So 3.1 is something called complex numbers. All right. So let's start with a little bit of what we know and what's new, and then we'll talk about some basics for what it means to be working in the complex plane. Okay. So let's take a look at this. X squared minus 4 equals 0. What's one way that I could start to solve this equation? Yeah, I can factor it, okay? And so what does that factor into if I choose the factoring route? Good. So x minus 2 times x plus 2 equals 0. Okay, so this is a really handy factoring shortcut to know. Okay, so when we have sort of our a squared minus b squared, we can factor that into a plus b times a minus b. Okay. Now, when we use that with this one, we get the x plus 2 times x minus 2. And then how do we solve for x in this case? Yeah, good job. So we're going to set one of them equal to 0, and we'll set the other factor equal to 0. Now, this idea we're going to use a lot in this unit, so I want that to be a really a good problem solving strategy that we have sort of in our back pocket, okay? And from here, we can solve and we get x equals 2 and x equals negative 2, okay? So that's sort of one way that we can solve that. I forget why that works. Okay, so Eric, that's a really good question. This works, okay, and this actually has a name. It's called the zero product property. And what that means is that if I take one number and I multiply it by another number, and at the end of the day, if I get 0, okay, this means that A equals 0 and or B equals 0. Because the only way to multiply two numbers and get 0 is that one of them has to be 0. Okay, good. All right, so this is one way that we can solve this. Now, I've had other students in the past say, well, what if I solve it this way? And they add 4 to both sides. All right, anybody out there do that? They just added 4 to both sides? Okay, now, what did you do next to get x by itself? Square root both sides. All right, did you get this as your answer? Okay, so this is a really important thing I want us to be on the lookout for. When we're solving equations, if we're taking a square root, Isis is exactly right, okay? It becomes the positive or negative square root. So if you solve the way in the blue, you lost one whole answer. okay? So if you are going to solve this way, you 100% need to make sure you have the plus or minus, okay? So totally valid to use both options, but if you don't have that plus or minus, you might lose the solution. So need this, all right? You need that plus or minus. Okay. So 2 ways to solve that equation, okay? Now we have an equation that looks super similar. All right, we have an equation that looks super similar. It's got the x squared, it's got the 4, it's got the 0. But hey, this one had a minus. This one has a plus, okay? So if we factor this one, can we factor it the same way? X minus 2 times x plus 2. Does that factor from x squared plus 4? No, right? That does not factor. So we can say that this is not a factor of that, right? Because the negative times the positive is the negative, exactly. Okay, well, maybe we try our other method then, which is move that number. So if we try moving the number, we get x squared doesn't equal 4 this time, but it equals negative 4. Okay. And now when I solve, we can still use Laura's strategy of square root, right? You can still use the square root. And I just made a big deal that we need to remember plus or minus. But what are we taking the square root of? Negative 4. Okay. All right. So if all you do is type this into your calculator, you're going to get a domain error, right? We cannot, when we work with real numbers, take the square root of a negative number. But what we can do is play around with this a little bit. So negative 4 is the same as 4 times negative 1. Yeah, 4 times negative 1 gives me negative 4. So can I take the square root of 4, like regular 4? Yeah, I can take the square root of negative 4. And then I still have this square root of negative 1 left. Okay. So that leads us right into our story for today, which is this thing, the square root of negative 1 is equivalent to I. Okay, so square root of negative 1 is the same as I. Now, some people like to write their I's like this, okay? I think sometimes that can get confused with a 1. So traditionally we do an I with a little tail, okay? So the tail doesn't have to be that long, but it's like a script I, all right? So it's not a backwards J, it's an I. Okay, so that is sort of why we need something called complex numbers, because sometimes we run into a square root of a negative, and in order to handle that, we use something called complex numbers, okay? So let's start by exploring the complex plane. So we know how to graph real points, and we're also going to be able to graph complex numbers. All right, so let's graph a little bit here. If I have a equals 2 comma 0, that means I'm going to go 2 out on the x-axis and nothing up on the y. So that's my point A, right? That we know how to do. And we could do the same thing here where we have b is 0 comma 3. So That's going to be B. And we could have C, which is -3 comma -4. So that would be here, and that would be point C, right? Any questions about graphing those 3 points? Pretty straightforward, I think. All right, so let's try graphing this one. All right. Now, for graphing that point, this first number tells us how far we go to the right or to the left. Okay. So this one is kind of like the X. That means that the 4 is kind of like the Y. Okay, so the first number is kind of like the X, the second number is kind of like the Y. So if I want to plot the 3.3 plus 4i, I'm going to go over 3 and up 4. And this is A, which is 3 plus 4i. So take a moment and plot B and plot C. All right, give you a moment to plot B and C, and then we'll check our answers together. All right, what quadrant is B in? First, second, third, or fourth? In the second quadrant. Good. So I'm going to go to the left 2 and up 1, and this is B, which is -2 plus I. Okay. And now for part C, or point C, what quadrant is point C in? It's going to be in the third quadrant. Good. I'm going to go 5 to the left and 4 down, and there's our C. Okay. And you can even see on the axes that we have our real axis. So that's like the 3 and the -2 and the -5. Those are all real parts of the number. And then we have this imaginary axis, which is the 4i, the 1i, the -4i. Okay. So it works very similarly to a real plane, but just we get the numbers from different parts of the point. Okay. So we can actually graph things on a complex plane, but we don't often. I just wanted to show us that we could graph points like that there. Okay. All right. So let's take a more mathy look at what we mean by complex number. Okay. So a complex number is any number that has the form a plus bi. Okay. Now a is the real part, and bi is what we call the imaginary part. Okay. So a real part and an imaginary part. If you get no imaginary part, then you have a real number. And if you have only the imaginary part, then you have an imaginary number. Okay. And so this right here is just a diagram to show you the real part is in the blue and the orange part is the imaginary part. And together, they make the complex number. Okay. So in this case, A is 5 and B is 2. All right. So let's practice some of our working with radicals here and thinking about factoring and what we know about square roots, okay? So Another way for me to write the square root of negative 81 is square root of 81 times negative 1, which is the same as the square root of 81 times the square root of negative 1. Okay. Now, we all know that the square root of 81 is 9. And that comes from, let's see, this is that. And how do we rewrite the square root of negative 1? Well, we write it with I. So we replace it with I. All right. So negative 81, if I take the square root of that, the answer is 9i. Now, Eric, let me just take a look at your question for a moment. You said 5 plus I over 2, like 5 plus I over 2, like that? Yeah? So A is 5, B is 1/2. Yeah. So that's okay. You can have fractions. That's okay. All right. Let's take a look at example 2. I've got a negative sign in the front. How can I split the square root of negative 200 into 2 square roots? Yeah, so we've got 200 and the other one is negative 1. Good. Okay. Now 200, I can break down into like square root of 100 times square root of 2. Okay. And square root of negative 1. Square root of 100, we know, is 10. So I have the negative sign in the front, so negative 10. Square root of 2, I can't do anything with. And then the square root of negative 1, we change to I. All right, so this becomes the I. This becomes the I. Right? This is one way to write your answer, but sometimes you'll see folks move the I before the square root. Okay, this might be a little bit more traditional. The only reason people do this is so they know that the square root doesn't go over the I, it only goes over the 2. Okay, that's really the only reason. Sometimes those square roots get real long and then you include the I underneath there when you didn't mean to. So this, the boxed off answer might be a better way to write it to prevent that from happening. All right, how can I break up 75? All right, how do I factor 75? 75 and 1, or 25, 3, and negative 1. Good. So 25, 3, and negative 1. I've got my term that's going to turn into an I right there. Whoops. So I get 5 root 3 I, or maybe more people write it like 5I root 3. So we don't get that I trapped under the square root. Okay. All right, let's do one more. Square root of negative 72, I can break down into square root of 9, square root of 4 and 2, and then the square root of that negative 1. And this is the part that will make the I. And so I'll get 3 times 2 times root 2 I, or I can write it as 6I root 2. All right, any questions about examples 1 through 4? I do want it to be fully factored, yeah. Okay. And you can certainly take more steps to factor it if that's helpful for you, but do make sure that it's fully factored. Okay. So very briefly, I want to talk about patterns of I. There's a lot more patterns, but if we focus on the first 4, I think that's going to be helpful in our simplification process, okay? So Ethan said this is more about powers, but if you multiply 2 numbers that are perfect squares, then the answer will be a perfect square as well, right? Yes, correct. Yeah. Okay. So we know by definition that I equals the square root of -1, okay? So when I say I squared, that means really I times I, right? I squared means I times I can replace I with the square root of -1, and then I can replace the second one with the square root of -1. So square root of -1 times square root of -1, what does that give me? -1, yeah. So even though I is imaginary, right? I is the square root of -1. We see from here that I squared actually equals -1. Now, I want us to put some stars around this because we're going to come back and use this a lot when we're simplifying, that anytime we see I squared, we want to replace it with a -1, okay? So anytime we see the I squared, we want to replace that with a -1. Eric, that's a really big question. And I think that goes back to our what we know. Some problems like the ones on the left, we can solve. And in order to solve problems like x squared plus 4, we needed something to handle square roots of negatives. All right. There's 2 other values of I that I think are nice to know. Okay, so if we take I cubed, another way I could think about that is I times I times I. Now, I know that I squared is -1, and then I is just I. So -I is equivalent to I cubed. I cubed is equivalent to -I. Okay, we don't use that one quite so much. And last but not least, I to the 4th. I can say that as I times I times I times I, which is -1 times -1, which gives us 1. Okay, so I to the 4th is equal to 1. All right. So, like I said, we're mostly going to be using the first 2, okay? But I did want us to know that the second 2 exist. All right, so anytime we see an I, we know that's the same as the square root of -1, but anytime we see the I squared, we have to replace it with -1, okay? So with that, let's take a look at adding and subtracting complex numbers, okay? So here's the deal. Adding and subtracting complex numbers is just like adding and subtracting things with like terms. We want to make sure that we combine like terms. And combining like terms is nothing more than adding or subtracting the real parts and adding or subtracting the imaginary parts. So like terms, when we talk about complex numbers, means real with real and imaginary with imaginary, okay? So let's actually choose better colors. What did the textbook use? Blue and orange. Okay. So in example 5, let's find all the real parts. I've got 7 and I've got 4. Those are the real parts, right? The imaginary parts are -3i and 5i. And so when I simplify this, when I add these two complex numbers, I get 7 plus 4, because those are the real parts, plus -3i plus 5i, because those are the imaginary parts. So imaginary, real. And then we add and subtract like normal. So 7 plus 4 is 11, plus -3i plus 5i is 2i. Okay? So when we add, pretty straightforward. What do you think is trickier about subtraction, like in example 6? Is -I the same as I squared? No. I squared is the same as -1. Okay. All right. So what do we think might be a little bit trickier about example 6 when we're looking at subtraction? Yeah, ISIS, that's exactly it. We need to distribute that negative. And same thing, David, we need to distribute that minus sign, right? So sometimes when I'm doing these kinds of problems, I just make it really obvious to myself, and I even write it out more. So 2 minus I minus 8 minus 3i. So I sort of get rid of the parentheses so that I can see exactly what signs I need to attach to the real and imaginary part. But once I've done that, we find our real parts, 2 minus 8, and we find our imaginary parts, minus I and minus 3i. And so when we combine all those, we'll get minus 6 and then minus 4i. Okay? So pretty straightforward in terms of adding and subtracting. Anybody have any questions on adding or subtracting? Okay. So let's move on to multiplying complex numbers, all right? So how do we multiply complex numbers? Well, we distribute and we simplify. And for some of us, maybe it's helpful to remember that acronym FOIL, right? You've heard maybe FOIL before at some point in your academic career. Anybody remember what FOIL stands for? Okay, so first, the F stands for first. So you take the first terms and you multiply them. You take the outer terms, the inner terms, and the last term. So that's where we get FOIL from, okay? So if we apply that to example 7, my first terms multiplied would be 2 times 5, right? Because 2 is the first term in the first one and 5 is the first term in the second one. Plus my outer terms will give me negative 2i. So when I take 2 and I multiply it by negative I get negative 2i. What do I get when I multiply my inner terms? (15i), good, 15i. And then what do I get when I multiply my last terms? Tell me how you got that. Yeah, okay. So 3i times negative I gives us negative 3i squared. Right, so everybody buy that? 3i times negative I gives me negative 3i squared. Okay. Now, I just wanted to make that point because Eric is correct. You do get 3 at the end because every time we see that negative 1, I said put some big stars around that, we need to replace with negative 1. Okay? So this is really going to give us, let's see, 10 plus 13i. Now let's be careful here. I have minus a 3. So minus 3. Okay, there's a lot of negative signs there. And now we can combine like terms one more time. Oh, sorry, I have one too many minus signs, huh? There's no minus sign there. This should actually be a plus. All right, so we'll get 13 plus 13i. And that's how we use FOIL even when we have complex number. Okay. Now, some of you may not really like FOIL, or like me, you find that you make a lot of sign mistakes. So sometimes what I do is I do like more of a visual way of combining my like terms and multiplying. So I would put like 2 plus 3i up here. And then instead of 5 minus I do 5 and then minus I. Okay, and I kind of use the idea of area to help me find the inner pieces. So like 5 times 2, this gives me 10. Okay, what would I put in this top right hand box? Yeah, the 15i would go here. In the bottom left hand, I would get negative 2i, and here I get negative 3i squared. Okay. So when I combine everything, I can see that I have 10 plus 3, that gives me 13. And then 15 minus 2i is plus 13i. Okay. So sometimes that gives me just like more of a visual, and I tend to make less sign mistakes with the box than I do with foiling. Okay, but I'll leave that up to you which method you prefer. So knowing that, take a moment and work through example number 8. Okay. Now take a moment, work through example number 8. So I've kind of set it up both ways, okay? And part of the reason I do that is, even on like a test or something, I might want to double check my work, make sure that what I'm doing is accurate. So this just gives me a different way to check over my work. So I can see from here that 3 times 2 gives me the 6. So that's good. That first term matches. I can also see that I've got a negative 15i, and I'm going to subtract 8i, which is good because I have the same thing here. And that will give me negative 23i. Okay. But what do we replace this 20i squared with? Negative 20. Very good. So I have a negative 20 here. Okay. Now I just need to make sure I clean up my terms. So all the real parts, I've got negative 20 and the 6, right? So together, those give me the real part. So I get negative 14. And then my imaginary part is negative 23i. Okay. So I don't think that the multiplication or the subtraction problems are really that difficult. I think it does require us to remember, though, everywhere we see that I squared, we need to replace it with the negative 1. Okay. And it requires us to be accurate about our signs and making sure that we're adding and subtracting correctly. Okay. All right. Any questions on the multiplication? All right. So let's get to the good stuff, the juicy stuff. All right. Dividing complex numbers. All right. So dividing complex numbers, we want to make sure that we are very clear on the process that happens here. Okay. So let's look at the how to first. So if we look at the how to, it says given two complex numbers, when we divide one by the other, we have to do the following thing. We need to write it as a fraction. And you'll notice that all the examples I give you are already as a fraction, okay? So I've done that part for you. The second thing you need to do is find something that we call the complex conjugate, but you want to find that of the denominator, okay? We're going to find the complex conjugate of the denominator. Then you're going to multiply the numerator and the denominator by the complex conjugate. And then you're going to simplify, okay? So we really need to focus on steps 2, 3, and 4. We need to find a complex conjugate. We need to multiply top and bottom by this complex conjugate. And then we need to simplify, okay? So knowing that, let's go back to this definition of a complex conjugate. So the complex conjugate of a number, a plus bi, is just a minus bi. And we can find that by changing the sign of the imaginary part of the number. We do not change the sign of the real. Okay? So don't change the sign of the real, only change the sign of the imaginary. Okay? So let's give that a try. Let's try number 9. All right. So 2 over 3 minus I is already written as a fraction. So what we need to figure out is the complex conjugate of the bottom. And then we're going to multiply that on the top and on the bottom. That's why I'm drawing a fraction. So if I have 3 minus I, what is the complex conjugate of that? 3 plus I. Good, because we keep the sign of the real part and we change the sign of the imaginary part. And whatever we do to the bottom, we also need to do to the top. We're not just changing it, we're multiplying by the complex conjugate. And that'll become clear in a moment why we're doing the complex conjugate. But by definition, the complex conjugate is when you change the sign of the imaginary part. So we're using the definition of the complex conjugate to find something to multiply our problem by. Now, maybe as a separate piece here, what is 3 divided by 3? It's 1, right? Okay. What about pi divided by pi? That's also 1. Okay. What about x plus 2 divided by x plus 2? Yeah, that's also 1. All right, what about 3 plus I divided by 3 plus I? That's 1. Good. Okay. So maybe the bigger part to this story is the reason why we're multiplying the top and number by a complex conjugate is this is a fancy way of multiplying by 1. And when we multiply by 1, we don't change anything. Okay, so even though I'm multiplying by these things in the blue, I'm not changing my original problem. As long as the numerator and denominator of this fraction I'm multiplying are the same. So let's see what happens. Like, why would we choose to multiply by a complex conjugate? Okay, so I think this might answer your question a little bit better, Eric. So if I'm multiplying, what I get now is 2 times 3 plus I. And on the bottom, I have 3 minus I times 3 plus I. Okay. And again, even though it looks a little bit more complicated than our original problem, this is our fancy way of saying 1. Okay. So let's multiply. What do we get in the numerator? 2 times 3 plus I. What does that give us? 6. Okay, 2 times 3 is 6. And then 2 times 1 is 2i. Good. So 6 plus 2i. Okay. Now on the bottom, we have to FOIL, right? So 3 times 3 gives me 9. Outer terms, inner terms, last term. Okay. Negative I squared is the same as plus 1. So 9 plus 1 gives me 10. What happened to the 3 i's on the bottom? Yeah, right? 3i minus 3i, that goes to 0. They get rid of each other. There are no more i's in the denominator. And that is good. okay? So Eric, to kind of go back to your bigger question of maybe like, why are we multiplying by this fancy way of saying 1? Well, our goal is to get rid of the imaginary numbers in the bottom. And one of the easiest ways to do that is to multiply by the complex conjugate. So we choose this complex conjugate because it will eliminate the i's in the denominator. Okay. That's why we multiply by the complex conjugate, because it gets rid of the i's in the denominator. Does that maybe make a little bit more sense in terms of why we're choosing this strategy? Okay. And by the way, thank you for asking these questions. I think that a lot of times we teach procedure, right? Like, oh, well, to do this step, then do this step, then do this step. But one of the questions I appreciate from you folks is like, yeah, but why? Because how are we going to know in the future with a brand new problem what we should do, right? And so this is really building that toolkit of what you should do. Now, in this case, we do want to break it up into the real part and the imaginary part, okay? So the real part is going to be the 6/10, and the imaginary part is going to be the 2/10i. Now, on an exam, do I really care? Probably not so much, honestly. My biggest thing is, do you remember to multiply by the complex conjugate? But in thinking about WebAssign, okay, sometimes they ask you for the real plus the imaginary part. So you might get the question right, but if you don't type it in a certain way, you might then get the question wrong. So my guess is WebAssign would probably want you to do like 3/5, right? We reduce our fractions plus 1/5 i. Okay, this is my guess for what WebAssign would want, but any of these three on the bottom for me, these are all okay. Me on like a test or quiz, okay? All right, let's take a look at example number 10, okay? So our goal in order to divide these is to get rid of the i's on the bottom. Right? We don't want any i's on the bottom. The problem is not the division. The problem is the -3i on the bottom. Okay, that's the problem. So our approach is multiply by the complex conjugate. So that's going to give us 2 plus 3i and 2 plus 3i. Now, sometimes I find it helpful to write it all as one fraction. Okay. And now it's nothing more than foiling on the top and foiling on the bottom. Okay. So I'll give you a moment to foil on the top and foil on the bottom, and then I'll start to show some of my thinking. All right. So when we're foiling, we should get something like this before we start simplifying, okay? Now I've highlighted the I squareds at the end, so I know that I need to replace that I squared with a -1, right? And I don't think that's a bad strategy to do as you're practicing your problems and also on an exam so that you don't make any small mistakes like this, right? And so when we kind of clean up the top, we get 10 plus 3 or minus 3. Yeah, Eric, it is sort of like that, the x squared plus 4. Mhm. Yeah, we're going to get minus 3, right? So 10 minus 3 is going to give us 7, and then plus 17i. So that's our numerator. Now in the denominator, here's a clue you did it right. If these cancel out to 0 and you've got no more i's in the denominator, then you've achieved your goal. Now this is not going to be -5 in the denominator, but it's actually going to be 13. Okay, it's going to be 13 because it's 4 minus -9, or 4 plus 9 to give us the 13. Okay. So on a test, this is totally fine for me, or on a quiz. But if we're thinking WebAssign, we need a real part plus our imaginary part. Okay. Any questions on example 10? All right. Let's go ahead and try one more variation, okay? One more variation. So when we're looking at this one, we see the division, we see the fractions, and we're like, oh shoot, we're gonna need that complex conjugate. 5 minus 2i, 5 minus 2i, right? We gotta do it on the top and on the bottom. Now, some people, when they see more than one thing on the top, they like to simplify that part first and then multiply by the conjugate, okay? So that's really up to you what order you want to do this in. But let's maybe simplify the top first, and then we'll multiply the top and bottom by the conjugate, okay? So we are going to keep this on the bottom. We're going to keep our conjugate. And when we FOIL out the top, we get 2 plus 4 minus 1 is plus 3i minus 2i squared. Oh, I squared. Okay, I'm going to have to replace that with a -1. So I end up with 4 plus 3i over 5 plus 2i times my conjugate. Okay. And now it's exactly like problem number 10. Okay, so really the complicated part was just that you have to simplify that first part before you then do the rest of the problem like you've seen. Okay. So we know the top is going to be 20 plus 15i minus 8i minus 6i squared. Oh, there's that I squared again. And the bottom is going to be 25 minus 10i plus 10i minus 4i squared. Oh, there's that I squared again. And did all the i's go away on the bottom? Yep, those went to 0. Woohoo! So I've achieved my goal. I now no longer have i's on the bottom. So what does this give us? Well, 26 plus 7i on the top. And then what's the denominator going to be? Is it going to be 21 or is it going to be 29? Yeah, good. It's going to be 29 because it's 25 minus -4, which gives us 29. And on a test or quiz, this is absolutely fine for me. You want to break it down for WebAssign, 26 over 29 plus 7 over 29i. Okay. All right. So before we stop this section, I just want to highlight like maybe one of the ways that I tend to study. So I think sometimes when we study, and I used to study this way, and I realized at some point that it wasn't very effective. So let's say I was going to study section 3.1. Sometimes we start all the way at the beginning and we're like, okay, let me go over it step by step. Yup, I'm going to practice graphing. I'm going to practice splitting up the radicals. I'm going to study the patterns of I. I'm going to study how to add and subtract. And maybe by this point, your brain is tired. And then you're like, I'll just figure the rest of it out later. And then later never comes. And then you get to the test and you're like, how come the problems all look like things I didn't get to study? Okay. So I don't know if that's happened to you, but that's happened to me before. So one thing that I started to do in my studying was I was like, I'm actually going to study backwards. So I'm going to start with the most complicated problems we have, the ones that require me to, like, in order to answer example 11, I need to know how to multiply, I need to know how to add, and I need to know how to subtract. So if I study questions like 11, I've already studied the other things that come beforehand, okay? Or even if I study questions like number 10, you're studying how to multiply, how to add, how to subtract, and you're studying the division. So like doing a lot of problems like examples 10 or 11 is probably more bang for your buck than sitting and doing ones that are only multiplication or ones that are only addition or only subtraction, okay? So that is something that I want to just kind of encourage you to try, is sometimes when you just start from the end, your brain is a little bit fresher so you can absorb it more, and B, you're challenging yourself to see the big picture, not just the small little parts along the way, okay? All right, so Yitan is filling out your reference sheet. Yes, okay. So that was a suggestion that a few of you have already started doing, which is at the end of today's lesson, take 10-15 minutes to make your reference sheet for 3.1 and 3.8, right? Then at least you've got a first draft going, and while it's fresh, you know what was important, and you also know what you need to study a little bit more, okay? So yeah, keep sharing those study strategies with each other. I know it's a lot, but what we're really building towards is a really successful Calc 1 experience, okay? That's the end goal, that when we get to Calc 1, that we feel confident about our skills, we feel confident about our studying strategies, and our ability to ask and answer questions, okay? All right, so I'm going to stop sharing my screen here. And I'm going to